Okay, this is Unit 3, Lesson 3, second semester, Math 7. Vocabulary review. Why is 5 plus 2 not an algebraic expression? Why is that not an algebraic expression? Go ahead, Jaden.
Because it does not have a variable.
Yes, it does not have a variable. No variables. And what type of expression is it? Help him out, Tata. It's a numerical expression. That's what that is. It's a numerical expression. There's no variables. Okay, so now we're going to evaluate the algebraic expression negative 4x plus 1 for each value of x. So they're telling you what x is going to be. You need to plug in the value for x. So here's my value for x. Each value of x. Okay? We're going to put these in to the algebraic expression, and we're going to evaluate it for those values of x. So here's my algebraic expression. Okay? So here's what we got. Negative 4 times some value of x plus 1. Mm-hmm. Okay, so now what I have to put in for x is the value they give me, which is negative 2. Well, here's some review for us. Now I got to simplify this. You guys follow order of operation. So Charles, what is negative 4 times a negative 2?
Negative 4 times a negative 2 will give you a positive 8.
Nice. Same signs give you a positive number when you multiply or divide. So I have a positive 8, and then I have plus 1. And now what's that going to be when I evaluate it for negative 2? What's the expression going to simplify to? It's going to simplify to 9. You could have if you tried to do this instead of sitting there. You can sign out and go to the restroom now. And the time is 10:29. Who's got this next problem, number 3? Who can walk me through this next problem? Somebody I haven't heard from would be nice. Cruz, what do we got here? What's my value for x? 0. So we're going to place that into my algebraic expression. So simplify this now. What's negative 4 times 0? It's 0. Very good. And then I still have this plus 1 over here. So then when I simplify my expression with x equals 0, what do I get back? 1. Get back 1. Okay, over here, next problem. My value for x is going to be a 4th. All right, so can I get a volunteer for this problem? So how am I going to go about this? Alexis, what's going on here? First thing I do is, in order of operation, is what? What do I have to do first here? Right. What am I going to turn to improper fractions? So you're on the right track. Yep. You're on the right track. You're really close. Go with your gut.
I'm going to change 1/4 into improper fraction.
Well, 1/4 is good. We're going to keep that. But I do turn something into a fraction. Negative 4. Can I turn that into a fraction? I could turn anything into a fraction, right? How? Somebody help him out. How do I turn? Put it over 1, right? So I have negative 4 all over 1, and I got to multiply that by 1/4, right? So we're going to do this right over here. So when I multiply these, what do I get back? Let's do some scratch work over here. What do I get back when I multiply these out?
Negative 4/4.
Alexis, come on. What's the numerator going to be?
4/4.
What's the numerator? What's negative 4 times 1? I multiply my numerators. What do I get back? Negative 4 times a positive 1. Numerators. Come on, that's how we multiply fractions. So a negative 4 times a positive 1 gives me a 4.
Positive 4.
It gives me a positive 4. Ladies and gentlemen, let's review the rules. If they're the same signs, what's the product sign going to be?
Positive.
Okay. If they're different signs, what's the product sign going to be? Right. So in the numerator, I have a negative 4 times a positive 1. What's that going to give me back? Gives me back a negative 4. Okay. And the denominator, I have 1, a positive 1 times a positive 4. What's that going to give me back? 4. And now I have a negative 4 over a positive 4. Remember, fractions is division. So if I have a negative divided by a positive, what's that going to give me back? A negative what? What is the negative number? What is it going to be?
16.
We're dividing. 4 fourths is 16? Since when? Come on. It's going to be 1. So, quiet please. So all of this is what we should be doing mentally, right? So this right here is really the same as negative 1. And then I have plus 1 right here, right? So what's negative 1 plus 1? Go on, look at your number line, turn around.
0.
Do you see where negative 1's at?
Yeah.
If we add 1, which way am I going to go?
To the right.
Okay, so where do I end up at?
0.
0. Stop shaking your head. Some of you guys get the same way. Now, who can help me out with this last problem? Because now that you've seen Alexis do the last problem, this one's pretty easy because now some of the stuff's fresh in your mind. Who's got this one? Chin, go ahead. So we're putting negative a fourth, right, times a negative 4. What's that going to give me back? Negative 1/4, right? Well, first of all, if we just think about the numbers. If I have a negative times a negative, what's my answer going to be? Positive, right? And we know if we take 4 times 1/4, what do I get back? 4 fourths, right? And 4 fourths gives me back 1. So you know this is just going to be a positive 1, right? When we multiply that out. And then over here I got plus 1, right? Now we need to simplify that. We're done with simplifying our algebraic expression. What's that going to be when we simplify that? 2. Very good. Okay. Moving along, here's our lesson for the day. And since I'm putting this on the YouTube channel, I'm going to go ahead and read this to you. What you'll learn: to write and evaluate functions. New vocabulary, function. Why learn this? The distance you drive in a car depends on the driving time. When one quantity depends on another, you say that one is a function of the other. So distance at the right and input go through the function machine to produce an output. Okay. Now, a function is a relationship that assigns exactly one output value for each input value. So if you put, remember we came up with some rules the other day? Okay. A function is kind of like a rule, all right? If you put a value in, you're only going to get one value out. Does that make sense? I'm never going to get back 2 where I have to guess which one is which. Do you guys understand? If I do have that, it's not a function. Okay, so we're just talking about functions for now. Functions, they call it a machine, but really it's just like, it ties with what we just talked about, an algebraic expression. It's something we can substitute into the expression, and we get one value out for that one input. Does that make sense? So, one output for every one input. Okay? Bryce, you have a question? 10:36. Okay, writing a function rule. Here's my first example. Cars. You're traveling in a car at an average speed of 55 miles per hour. Write a function rule that describes the relationship between the time and the distance you travel. Okay, so our input is time and our output is distance. So if we were to think about this as a function, and just to get you guys familiar, a function where We know the hours. Okay. And that's going to equal, well, here's what we got. The number of hours, I'll just call it H. Over 1 times 55 miles per hour. And maybe instead of H, I should have put, I'll put X. And those will be in units of hours, X hours. Okay? Now, if I was to substitute 1 hour into this function, what would I get back? Do you guys see that my units cancel, H and H? Okay. So if you see the units that will cancel out, this will give me back my output. So somebody tell me what my output's going to be for 1 hour. 55, right? Did I get more than one answer? No, I just got one answer. So I have one input, 1 hour. That means I go 55 miles. What about 2 hours? Okay, let's try to raise our hand. Who's got that? 2 hours. Very good, thank you. 110 what? Okay. Who's got 3 hours? How far are we going to drive in 3 hours? Somebody get that? Charles, how far are we going to drive in 3 hours?
165.
165, very good. Okay, and what about in 4 hours? How far are we going to drive in 4 hours? Michaela?
220.
To what?
220 miles.
220. Was there ever a situation where we put in the number of hours and we had to guess what the answer was going to be? We only got one answer out. So do you guys understand what they mean by for every one input, we get one output back? Do you guys understand? We never get 2 or 3 where we have to like ask which one it is. It's obvious. It's just one result for every one input. You guys understand? This is like at the heart of what a function is. Okay, moving along. All right, here's what I need you guys to do. I need you to write a function rule for the relationship between the time and the distance you travel at an average speed of 62 miles an hour. So this is very, very similar to what we just did. I need you to write a function rule. So who's got a function rule for me? Somebody I haven't heard from. Robert. What is it? 62. Okay, remember we saw that there's a common difference. But do you remember in lesson 4, the common difference was always where when we had the variable. Do you guys remember? Do you remember that, the rules we wrote? There's 2 ways that we did it for lesson 2. Remember in lesson 2? We can use the common difference. Right, that's what I'm trying to get you. Remember, we could times it. Do you guys hear what he said? And so I actually said a different way. I said, hey, the common difference ends up being the coefficient in front of the variable. So that's where I'm going to get to next, and that's exactly what I was trying to lead us to, which is, so if our function, and you're saying time, t, okay, equals, well, we have our, it's increasing by 62 miles every time, 62 times t, so 62t. Got it? Right, our time t. Okay, and I could have written that the same way up here. I could have said function of time equals 55t, right? Will give me the same result, okay? So we're going to need to be able to write these rules eventually. But right now we're just getting familiar with what makes a function a function. So can we go ahead and use this function that Robert gave us to fill in the rest of this table? What is my output going to be for a time of 1 hour? Somebody haven't heard from me. Tata, go ahead.
62.
It's going to be 62. So we have 62 miles. What about for a time of 2 hours? Gabby? 124. Good. What about a time of 3 hours? Who's got that one? Michaela? 186. And who's got a time of 4 hours? Anybody? Nima? 248. Okay. So far, pretty easy? Okay. Anybody have a question for me? What's your question, Shin? You good? Okay. All right, moving along. The variables x and y are often used to represent input and output. Okay? You can describe the relationship between the values in the table in 3 ways. Okay, so just to kind of tie this in with what we showed earlier, input, output. So here is my algebraic expression, x plus 3, right? You guys see that? So the way you would see this as a function, sometimes I'll write it as a function, the function of x equals x plus 3, okay? And, you know, y is just the result of x, of the function of x. Do you guys understand? So if I plug in x and I simplify this expression, that's what y is, but that's also another way to write the function. So let me show you guys how to think about this. Because when I was trying to learn this stuff, I kind of wished my teacher taught me this way. So you have your function at x, and then here's my expression, x plus 3, and then whatever that is going to be my y. Does that make sense? Okay. So let's take a look at my table, and let me make some more room for us. So I'm going to slide this down a little bit. So if we take a look, and I'm going to rewrite this. So here's my function, and if we look at my table, I'm going to choose the first one. Actually, let me go ahead and choose my function at 2. So instead of x, I'm going to put 2 here, and then I'm going to replace my x's with 2, 2 plus 3. And then what is 2 plus 3? It's 5. So do you see how I just wrote this? Do you guys understand? Okay. So I have my function, and the variable of the function is x. Okay. You can have some functions that have more than one variable. Okay, but function with x, that's the expression, or the expression with x. And then when I substitute for x, I get back a y. Do you guys understand? So here, I said, hey, my function's going to be evaluated at 2. And then here's the algebraic expression rewritten where x is replaced with 2. And then here's the algebraic expression, just like the warm-up, where we simplify it and we got 5. Do you guys understand? So if you look, here's my 5. And there's my 2. And there's my 2 again. Does that make sense? Any questions? This is just notation. So if you see it written out this way, it throws some students off, but it's really not that complicated. All right, so if you notice, what is the common difference for all my outputs? It's +1. Nice. So if you agree with Michaela and you saw that each of my outputs had a common difference of +1, What's the coefficient in front of x? Or what's the number that's in front of x? Is there no number there? Is there a number in front of x?
No.
But we can always put a number in front of x. What number is that?
1.
1, because 1 times anything is that number, right? So do you see that I could actually put 1x, right? And that's what our common difference is. Do you understand? Are we good? Okay. So I'm just trying to tie this back to what we're doing. Okay. Now, if you guys remember lesson 2 and how we had to make that little adjustment once we identified the common difference. So I'm trying to give you guys a trick, kind of like a set of things to follow, a cookbook method to figuring out what the rule is. So here's our input and our output. We need to come up with our rule to represent the table. So the first thing we have to do is what? Think about what I just talked about. What do we have to figure out?
The function.
Well, we're trying to figure out the function, but I'm trying to tie this back to what we did in lesson 2. Remember that? What did we just find here in the table that Michaela just told us? There's a common difference, right? So let's take a look at this. Is there a common difference for my outputs on that first table? What's the common difference? I hear -4. Is that true? Is it -4? -4. Is that true for every term? Or every output? It is. So guess what? We know that we have an input x, right? What is the -4? Where does that go? What's happening with -4? Robert, do you remember what we just talked about earlier? What do I do with that -4? I'm going to multiply it, remember? So my common difference, I multiply it to my input. But now I got to make an adjustment, right? So if I put in 0 for x, do I get back 0 for y? Does it work? It does. So does it work for all of them? Now let's check them all. 1 times -4, does that give me back -4? Yes. 2 times -4, does that give me back -8? Guess what? We got our rule. Here's my rule. I got my function at x equals -4x. I don't have to adjust that rule at all, right? Now, let's take a look at this one. This one's might be a little bit different, right? First thing we have to do, Chin, what's my common difference? Are you sure -2? It's add 2. So remember, when we're talking about negative numbers, the thinking is a little bit different. So hold on. I'm trying to give you like a cookbook method. So first thing you got to figure out what's the common difference, and you said just 2 or +2. Do you guys agree it's +2 for all these? Okay, so here's what we got. I got some function. My function evaluated at some x, right? Well, what do we know about 2? 2 is going to be what? Remember what Robert said? Gabby, can you help Chin out? It's no, +2. It does have something to do with our variable. What about it? Take a look at our first example and then look at the one we're working on now. It's going to be our, who remembers? Robert, can you help them out? They forgot again. You're going to take your common difference and you multiply that to your variable. So here, I'm going to put 2 in front of the x. So 2 times x. You guys got that? But now we got to substitute into our x our input and make an adjustment so that we get the right output. Does that make sense? So Chin, over here when we put 0 into my function, it gave us the right output. Do you see that? Now, over here if we put 0 in, does it give us the right output? So 0 times 2, does it give me -3? No. How do I fix it so it will give me -3? I have to add or subtract something to this. What's it going to be? So if I add 2, isn't 2 times 0, 0, and then +2, that gives me +2. I don't want +2, I want -3. How do I fix it? Atisha. No, go ahead. We're learning. It's okay for us to trip up.
It's going to be negative.
Right, it's going to be a negative number to fix it, right?
It's going to be negative.
You said -2, but is that going to give me what we need? Because if I put 2 times 0, that's 0, and I subtract 2, that gives me -2. And it's going to be -3. There you go. So it's okay. You said negative, and you got the ball rolling. Everybody else started picking up on it. So now, is this true for the rest of my outputs? Can I take another input? Let's try the next input. What about 1? If I have 2 times 1, what's that give me back? 2. And then I take away 3, what's that give me back? Does that work?
Yeah.
Gives me the right output? Okay, now let's try 2. 2 times 2 is what?
4.
And then -3, what do I get back?
1.
Is that true? Is that the correct output? I think we got it. So do you guys see how I'm trying to show you like a cookbook method? Okay? All right. Now let's see if you guys got this. Can you find a function rule to represent this table here? It's just turned, my table's not up and down anymore. It's just a T-chart sideways now. Now I walked you through 3 examples. I want you to try to figure this out. Shh, 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 shh. I need you guys to figure this out. We've gone through 3 examples. I don't need you calling out now. I feel like we've seen enough that you guys can work on this and figure this out. I gave you a cookbook method. Let's try this. I need you to write this out. Write it out. Who's got the common difference? What is it? It doesn't change. It's add 4 every time, right? And so, what's my function going to be, right? What's my function going to be? Shh. All the way in the back, what is it? So you said 4x. Very good. So the 4x is correct. And did you have to make an adjustment to make it work out? What was your adjustment? You had a -3. So let's test this out. If I plug in 1 for x, I should get 1 back. 4 times 1 is 4 minus 3. Does it get me back 1? Yeah. Okay, what about 2? 2 times 4, 8. Minus 3 is what? 5. I'd say that was a pretty good job. Good job. All right, almost through. Give a function rule you can evaluate for the function for any input value. Okay, use the function. Here's the function. Okay, find y for these values. Then make a table for the function. Well, all they're saying is just evaluate it. So what's the value going to be if I replace 0 into that equation? It's going to be, it'll be 5, right? And what about if I put 1 in? What's it going to be then? 2, very good. And what if I put 2 in? What do I get back? -1. And then you should already see that there's a common difference here, right? It's subtracting 3. Look what's in front of my x. Subtract 3, right? And so what's this going to be down here? -4. Moving along, we're almost through. Shh. Use the function y equals 2x minus 4. Well, what's my common difference going to be?
2.
Add 2, right? Okay, they want us to plug it in for 0, 1, 2, and 3. So at 0, what do I get for my y?
4.
I get -4, very good. And then what?
-2.
-2, right? And then what? 0. And then what? 2. How many of you guys actually substituted in? How many of you guys just said, okay, I know the common difference, boom, done. Okay. That doesn't always work, so be careful, but it's working for the equations that we're learning. They're called linear equations. Okay, complete with at least or exactly 1. Every function pairs blank output with each input-output. Every function pairs blank output with each input value. Exactly 1. It's exactly 1. Okay, next one. Use the information from the function table to answer the following questions. Here's our function table. What number does the function pair with 3? 15. Okay, if we input 3, we get back 15. Describe the pattern that in the table using words. So you see, what's the common difference? Plus 5, right? Plus 5. Okay, remember if we're adding the same thing over and over to get to the next term, what is that? Do you guys remember? It's a sequence. What type of sequence was it? It was an arithmetic sequence. And it was an arithmetic sequence with a common difference. Common difference of what? Of 5. Now, we need to figure out the last thing, which is the function. What is the function of x going to be? What's the coefficient of x? 5. And do we need to make an adjustment so that it gives us the right output? No. We could just put plus 0. Did I make that wrong? That's correct. It's the same function, right? As just 5x.